Hello and welcome to this video. In this video, we're going to solve uh, some problems related to chapter 2. It's tutorial chapter 2 of general physics, and it's from Problems University Physics. So the question number 1 is 1 to 3, that's 3 part. The car travels along a straight road along the x-axis so that its position is given by a function of x, which is this, where t in seconds and x in meters. Calculate the average velocity of the car between time t1 is 0 to time t2. We take this as 10 seconds. Okay, so we wanted to calculate the average velocity. So we have x of t as a function of time, which is 2t squared minus 0.1 t cube. So what we're going to do, we wanted to find the average velocity between time interval time t1 0 to time t2 equals to 10 seconds. So what we're going to do, we put the value of t1 and t2 in this function. So we will get x1 or 0. So when we put t equals to 0 over here, it's going to be 0, and t over there is going to be 0 as well. So this is x1 going to be 0. So when we substitute x2 like 10 seconds, so we will get 2 into 10 square minus 0.1 10 cube. Okay, so we will get an answer 100. So this is your x2 at 10. Okay, so what is the formula for the average velocity? So V average is x2 minus x1 divided by t2 minus t1. So your velocity will be x2 is 100 minus 0, t2 is 10 minus 0. So we will get 100 divided by 10, which is 10 meter per second. So there is no option 10, so we'll make it this 10 meter per second. So option D is correct, or you can create an option E, which is 10 meter per second. So we have answer of this. Now move to the question number 1. Question number 2, the coordinates of the particle in meters is given by this function, where the t is in seconds. The particle is momentarily at rest, which means it's instantaneous is 0, or its velocity at momentarily is 0. So we are given by a function x of t, which is 16t square 3.0 t cube. So its velocity is instantaneous is dx by dt, which is 32t minus 9.0 t squared. Okay, or this is not t squared, so this function is not t squared, it's t, only t minus 3.0 t cube. You have dx by dt, which is your v instantaneous, is 16 minus 9.0 t squared. Okay, because its velocity is momentarily at 0, so we substitute this function 16 minus 9.0 t squared equals to 0. so which we get 9.0 t equals to 16, and t squared is 16 over 9, and we get t is plus or minus square root 16 divided by 9, and we get plus 1.3 seconds, and we ignore the negative time because we are going forward in time. So the option B in that case is correct. So moving towards the next question, a car is initially at rest, travels 20 meters, initially at rest. So this is an information, initially at rest. Initially at rest means its initial velocity is 0. It travels 20 meters along a straight line, which means this is your x. 4 seconds. This is your time. With a constant acceleration, the acceleration of the car is, so we wanted to find the acceleration of the car. Okay, so we have three equations of motion which we're going to use, because we have x and t and v naught of x. So we're going to use x equals to x naught plus v naught of xt plus 1/2 axt squared. So x is this going to be 0, this is going to be 0 as well because v of x naught is 0. So we left with 1/2 axt squared. So we left with 1/2 axt squared, and then our ax is given by, this is 2x divided by t squared. So 2 multiplied by 20 divided by 4 square, because we have 20 meter distance and 4 seconds time. So we left with an answer 40 divided by 16, which is 2.5 meter per second squared. So we have option C in that case, 2.5 meter per second squared. Moving towards the question number 4, a car is traveling with constant acceleration. Constant acceleration increases its speed from 10 meter per second to 50 meter per second over a distance. How long? It means we need to find t. So what is this? This is v naught of x, this is vx, and we are given by x as well, and we wanted to find the t. So we wanted to find t. So if we use first equation of motion, which is vx, which is v naught of x plus ax of t. So in that case we have vx, we have v naught, we have t, but we don't have a. So t will be from this equation will be vx minus v naught of x divided by a. So if we have t, if we find t, then we can use this equation to find value of this. Okay, or we can use another formula which says that the distance, or the distance which is the average velocity multiplied by the time. Okay, so this is average velocity when the acceleration is constant. So when the acceleration is constant, average velocity will be v naught of x plus vx divided by 2 multiplied by t. Okay, so we can get t is 2 v naught of x plus vx v or t is 2s over v naught of x plus vx. So we have t 2 multiplied by 60 divided by v naught of x is 10 plus we have 50, and then we have 60 will be cancelled out with 60, and t is 2.0 seconds. So we get an answer with A. You can use this equation as well. Find ax. We can find ax by 2ax x minus x naught, which is equals to vx squared minus v naught of x squared. So we get ax, which is vx squared minus v naught of x squared divided by 2ax divided by 2x minus x naught. So when we substitute the value, we will get ax, and when we get ax, we can substitute over here to find t, which will give you the same result. Now the question number 5. At time t equals to 0, a ball is thrown straight up from the ground level with the speed 50 meter per second. Find its speed after 1 second. So if we wanted to find speed, this speed is v naught of x. It's given to you, and the object is throwing upward. It means this motion is free fall. So we're going to use the free fall equation of motion. So we are given v naught of x is 50, then time is 1 second, and your a is g, which is minus 9.8 because the ball is going up. Okay, so we wanted to find its speed, which is vx. So we get vx from equation number 1, which is vx v naught of x minus gt. So vx is 50 minus 9.81 multiplied by 1. So what we get is 40.2 meter per second, which is this option. Now the question number 6, which is very important because you are given by a graph, which is the position or the distance versus time graph, and you were asked to find the instantaneous velocity at t equals to 6 seconds. So we wanted to find the instantaneous velocity. For that matter, we take a tangent line that passes the 6. So we have to find the instantaneous velocity by taking the tangent. So how can we take the tangent? We use this a 2-point formula. We select this point, and correspond to this is that distance. If you say that this is 5 meters and 5 seconds, then we have time. Okay, so this is your x1. So at this point your x2 is 0. This is your t1 and this is your t2. So you find v instantaneous is x2 minus x1, t2 minus t1. So x2 is 0 minus 5 and t2 is 6 minus 5, which is minus 5 meter per second, which is negative sign, shows that its velocity is decreasing as well, Okay, so we get an option B, which is 5 meter per second. Question number 7. Question number 7. A cat walks in a straight line along the x-axis. The cat's velocity as a function of time, is shown by the graph. So if you see the graph, the cat velocity is decreasing. Okay, so calculate the acceleration at t equals to 3 second. A calculation. So we wanted to calculate the acceleration at t equals to 3 seconds. Okay, so we will get similar kind of from question number 6. What we did, we select 2 points at this point, and at t equals to this point we select that point. Okay, so we have this point and this point. Okay, so here's your, this is your v1. Okay, and this is your v2. So this is your t1, which is 0, and this is your t2, which is 3. So your acceleration at t equals to 3 seconds, which is v2 minus v1, t2 minus t1, which is given by 4 minus 8 divided by 3 minus 0. So we will get minus 1.33. So here is your answer. Then find the cat's velocity. Find the cat's velocity at 3 equals to 7 seconds. So we wanted to find the cat's velocity. So cat's velocity at 7 seconds, and over here it's Vx is v naught of x plus ax of t, and ax we get from here. Okay, so v naught of x, it starts its motion and slowing down. So this is your v naught of x starting point, which is v naught of x. So this is 8. We get this minus 1.33, and time is 7 seconds. So we get the velocity, which is minus 1.3 meter per second. So here is your velocity, 1.3 second. So the next question is question number 8. Two automobiles are 150 kilometers apart. Two automobiles are 150 kilometers apart and traveling towards each other. So let's suppose we have, starting over here, so we have this car number 1 and this is your car number 2. Okay, so this is car number 1, this is car number 2. So they are traveling towards each other. This is going in this direction and this is going in this direction, and they are 150 kilometers apart. They are 150 kilometers apart. Okay, so we select this x naught equals to 0, and at this point, which is 150 kilometers apart. Okay, and one automobile is moving with 60 kilometer, which means this is moving 60 kilometer per hour, and other is moving with 40 kilometers per hour. So if we take this direction to be positive, we take this direction to be negative. Okay, so what we wanted to find, in how many hours they will meet each other. So when they meet each other some point, it means their distance from that point to that point will be equal, or they meet at certain point when they have the equal distance. Okay, so your x for car C1 will equal be to x car C2. Okay, so what is your x equation? X equation is x naught plus v naught of x C1 for car 1 t plus 1/2 ax t. Okay, and then we have x, this is x, the starting point x, which is 150 kilometer apart, then v naught of x C2 plus 1/2 ax C2 t squared. This is t squared as well, this is t squared as well. Okay, so now this point is 0, but this point is not 0. Okay, so when they stopped at certain point, they meet, their acceleration will be 0. Okay, so we left with v naught of x C1 t equals to x plus v naught of x C2 t. Okay, so we get t from here, which is v naught of x C1 minus v naught of x C2 t equals to x. So your t will be v naught of x C1 minus v naught of x C2 so your of x C1 x C2, so your t will be x over v naught of x C1 minus v naught of x C2. So when we substitute x, which is 150 kilometer, and 60 minus 40, and the velocity is minus 40, so we will get 60 divided by not 60, 150. So 150 divided by 60 minus the 40, because this is moving in the negative direction. So we will get 1.5 hour. Okay, so the next question is a car travels 140 kilometers at an average speed of 80 kilometer per hour, and then travels to 40 kilometers at an average speed of 40 kilometer. Okay, so now going to solve this question number 9, which is a car travel 40 kilometers at an average speed of, okay, the car is 40 kilometers with an average speed of 80 kilometer, and then travels 40 kilometer with an average speed of 40 kilometers per hour. The average speed of the car for this 80 kilometer trip. So we have like this, from this trip you have 80 kilometers, but he travels from this point x naught equals to 0 to x1 equals to 40 with a speed of 80 kilometer per hour. and then next 40 kilometers, which is x, now it's x2 is now become 80. So this travel is 40 kilometer per hour. So we wanted to know the average speed. So the average speed, V average speed, is the total distance divided by the total time. So we have the total distance from here to here, which is 80 kilometer, but we don't have total time. So what we're going to do, we calculate time, and then we're going to put the value of time over here, then calculate the value. So how do we calculate the time? So if you start over here, if you are in this interval, he from this position to this position, he traveled 80 kilometer. So we have the V average velocity, which is x2 minus x1 divided by t2 minus t1. So your V average is given by 80 kilometer per hour. Your x2 is 40 minus 0. You start from here, which is 0, and your t2 now become your t1, or time t1 in that time interval. This is your one interval, this is your second interval. So this is your one interval time. T2 minus T1, this is 0, T1 is 0, and T2 become Ti, which is in the first interval. So we will calculate this time. So this time is T1, which is 40 divided by 80, which is 0.5 hours. We got T1 in the first time interval. Now from here to here, he traveled with the force 40 kilometer per hour. So V average in that case is your x2 minus x1, or what you call this in the second interval, x1. So t2 minus t1. Now your x2 is 80 kilometers, your x1 is 40 kilometers, your time t2 is now your time interval t2 in the time interval 2 minus your time interval 1 is time interval 1. So your average velocity become, this is your 40, this is 40 as well, and you have time interval t2 minus, this is your time, this time interval is this, which is 0.5 hour. So you get your time interval from here, which is time interval 2, which is nothing but minus 0.5 equals to 40 cancel out, will be 1. So we get t2, which is 1.5 hour. So the time taken from here to here is 1.5 hours. So we substitute over here, we have total distance 80 kilometer per hour, and then we have time, total time, which is 1.5 hour. Okay, so we will get the total distance is 80 kilometers, not kilometer per hour. So we have 53 kilometer per hour. So your velocity will be 53 kilometer per hour. The last question of this tutorial is given: an object is dropped. When the object is dropped, the window of tall building, it hits the ground at time t second, 12 second. The height of the window above the ground is, the object is dropped. When the object is dropped, it means its initial velocity its initial velocity is 0. Okay, it take 12 seconds time. What we wanted to find the height of the building from where it dropped. For example, it dropped from that height. Okay, and we wanted, and it hits the ground 12 seconds later, so we wanted to find this height. Okay, so how do we calculate? We use second equation of motion, which is y equals to y naught plus v naught of yt plus 1/2 gt square. We take g to be positive because it's going downward. Okay, so y naught is this point. We start from here, it's a 0, so this will become y, this will become your height h, then v naught of y is 0, you will left 1/2 gt squared. So 1/2 9.81, your t is 12 seconds, and you will get the answer h, which is your height, is 706 meters. So in that case, this is your answer. Okay, so we have solved the 10th question. Thank you for watching us. Thank you.